Hey math kids, today we're going to talk about the area between two functions, and I think we just have two examples. Yep. So the first two functions we're going to look between. Hold on. Okay, so we have y equals x plus 2, and we have y equals x squared plus x minus 2. All right, so a couple things. We want to put this into an integral, and what we're going to do is we're going to take the upper function minus the lower function and then integrate. So we need to find the upper function, so we need to find where they intersect is the first thing. So we're going to set them equal to each other. And of course, you could graph this on a calculator and find that, but I want to show you how to do it by hand because potentially on the IB test, you will have to do this by hand. So I'm going to subtract x, subtract 2, okay, because it's quadratic. So that's 0 equals x squared. These cancel, minus 4, all right. Put that 4 back because that x canceled. It made the algebra easier. We square root both sides, and we end up with plus or minus 2 is equal to x. Okay, so we have a parabola, we have a line, and they cross. This x value is negative 2, this x value is 2. That's what we just found. Okay, so those are going to be our limits of integration. Now, because I know this is right side up parabola and this is a positive sloped line, when I'm looking at this, I know that the line is above it. But if you're ever not sure, if you can't conceptualize what these look like, you can always choose any number in between here, plug it in for both functions, and see which one gives you a higher value. Now I'm going to plug in 0. So if I plug in a 0 to the top, I get 0 plus 2, and so the answer is 2. If I plug in a 0 here, I get 0 squared plus 0 minus 2, and those simplify to negative 2. Since 2 is greater than negative 2, this is the top function, so, or the upper function. And so we get x plus 2 minus x squared plus x minus 2 dx. Okay, we set up our integral. Once it's set up, hopefully it's pretty straightforward. So first I'm going to distribute a negative. So I have x plus 2 minus x squared minus x plus 2. So I just changed all those signs. Now I haven't taken an integral yet. I'm going to simplify this before I do that. So I get negative x squared, and then x and negative x, those cancel, and then 2 and 2 makes 4. I don't know what I'm doing. There we go. Okay, now I'm going to integrate this. It's just a polynomial, so it should be pretty easy. So x to the third, and then 4x. And I'm going to evaluate that from negative 2 to 2. So if I plug in a 2 right here, looks like that. And I subtract that, and now I plug in a negative 2. Okay. So this becomes 8. This becomes negative 8 thirds. So I have negative 8 thirds plus 8 minus, this will be negative 8 times a negative, so that's positive 8 thirds. And this is going to be negative 8. Move that down just a bit. Okay, distribute the negative. Negative 8 thirds plus 8. Then I have negative 8 thirds over here plus 8. All right, So the 8's combine to make a 16. The negative 8 thirds combine to make negative 16 thirds. And we can multiply this by 3 over 3. So 16 times 3 is 48. So we have negative 16 thirds plus 48 thirds. So that gives us 32 thirds. And once again, that's an area, so that would be units squared. And it describes this region between the parabola and the line. Okay, let's try another one. This time they give us y equals x cubed minus 6x plus 3. And they give us y equals x squared plus 3. Okay, so once again, we need to find f upper and minus that from f lower. Okay. And when we're doing that, we set those equal to each other to find these limits of integration from a to b. So I'm going to say x cubed minus 6x plus 3 equals x squared plus 3. We get all of this on the same side. So we're left with x cubed minus x squared minus 6x, and then those 3's cancel, which makes it nice so we can factor out an x. We can t factor. We end up with x plus 2, x minus 3 times x, all equal to 0. So that gives me x equals 0, negative 2, positive 3. Okay, those are the places that it crosses. And so for each region, we actually need to know which one's on top, which one's not. So if you want a visual, this has a positive coefficient out here, so it goes up, down, up. Now, let me actually get rid of the axes because that's not really that useful for us. And then this one is a parabola. And so the parabola probably does something like that, since it crosses 3 times. And so this point is going to be negative 2. This point is 0. And this point is 3. So my guess is it's above right here and it's below right here. Now, to test that, we always want to test that. I'm going to plug in a negative 1 because that's going to be in between here. And I'm going to plug in a positive 1 to just double check. So right here, I plug in a negative 1. And I plug in a negative 1 here. Okay, so when I do that, I get negative 1 plus 6 plus 3. So that's 9 minus 1, so that's 8. When I do this, I get 1 plus 3, which is 4. So since that function is greater, yes, it is the white function, which is this function, is above. Okay, now I want to double check with 1. It should work out. But if I plug in 1 here, I get 1 cubed. Let's do that. 1 cubed minus 6 times 1 plus 3. So that's just 1 minus 6, which is negative 5, plus 3, which is negative 2. Then I plug in a 1 squared plus 3. So 1 plus 3 is 4. So yes, the blue one is on top. Okay, so my drawing does represent the function pretty well. So we need to switch it though, because we have a couple things going on. First we go from -2 to 0. So that's going from here to here. And our upper function is the white function, which is here. So that's x cubed minus 6x plus 3. And then the lower function is the other one, x squared plus 3. Okay. So this yellow only represents this piece of the area. Okay. Now in red, I'm going to write that piece of the area, and that's going to be here. I'm going to zoom out. Let's see. I'm going to write it over here. So we're going to go from 0 to 3, and since it's yeah, so we're going to add those areas together. So we go from 0 to 3, and this time the upper is the blue function, so it's x squared plus 3 and minus the other function, x cubed minus 6x plus 3 dx. Okay, now we just need to combine these, so I'm going to distribute negative, so it's negative x squared minus 3, and when I combine it with all these pieces, this 3 and this -3 cancel, and then I have x cubed minus x squared minus 6x dx from -2 to 0. And then when I do this one, I'm going to add it over here, 0 to 3. And so I distribute this, and I get -x cubed plus 6x minus 3. Once again, this 3 and this -3 cancel, and we're left with -x cubed plus x squared plus 6x. Okay, that's from 0 to 3. I'm just going to transfer this over here. So we have one problem that we can focus on. All right, now it just comes down to doing this by hand. Okay, so we take the antiderivative, and there's high potential to make mistakes on this. Okay, and then we get negative x to the 4th over 4. And we get x cubed over 3, and then 6x squared over 2 from 0 to 3. Okay. Now, if we plug in a 0 for all of these, it's just going to be 0. And then we subtract what we get when we plug in a -2. I'm not going to go through that, but if you plug in a -2 for all of the x's, or I guess each piece, I'm going to get -16 over 4, -8 over 3, and then 12. All right, so that's that. And I'll change colors, plus. So the bottom part is just 0 again. Now if we plug in a 3, we end up with -81 over 4. And I'm going to go just kind of quick through this. 27 thirds, and then plus 27. So that was 27. That's hard to read. 27. Okay. So we need to, simplify in here, distribute that negative, simplify in here, and when we do that, let me just do that real quick. So 12. Okay, so I'm going to get if you do that, you should get 253 over 12. And that's units squared. Okay, if you need additional help, please come to MathLab. Until then, calculator.